Hi everyone, Shaun Wassell here from CBT Nuggets. When most people think about getting into video game development, almost always the first recommendation that they encounter is that they learn either Unity or Unreal Engine. However, if you're a Python developer, the good news here is that you don't need to worry about learning these platforms, you don't need to worry about the rather steep learning curve that comes with them, and you don't even need to worry about learning another programming language such as C# or C++. The fact is that the Python ecosystem has several options for both 2D and 3D game development, and what we're going to be seeing how to do in this video is use Panda3D, which is without a doubt the most popular and full-featured game development framework available for Python. We're going to be seeing how to use Panda3D to create a simplified version of the incredibly popular video game Minecraft. Now, as you'll see in this video, the Panda3D framework is very straightforward to work with. The entire game that we're about to build, which includes logic for loading and displaying different types of blocks, basic terrain generation, navigating using the mouse and keyboard, as well as placing and removing blocks, all of that logic can be expressed in Panda3D in just over 250 lines of code, which is pretty impressive. So anyway, let's jump right in here and see how to build this thing. And just as a reminder, if you like what you see here, I highly recommend you check out our extensive library of IT and software development training on cbtnuggets.com, and also subscribe to our YouTube channel. So with that said, let's get started. All right, so first things first, let's set up a basic Python project for our game, and the good news here is that this is about as straightforward as it gets. It's pretty much the same as setting up any other type of Python project. So what you're going to want to do is just create an empty folder, right? I've called mine Panda3D Minecraft, and inside here we're going to set up a virtual environment using virtual env. Obviously there are other options here if you're comfortable with something else, but that's what I'll be using here. So let's get started here by running python 3-m venv. That will set up our project here with virtual env. And actually, by the way, if you happen to get an error running that, you're going to want to check your Python version by running python 3 and then -- version. And I'm using 3.8.9. If you're using something different, just keep in mind that that might cause some errors to occur with the commands that we run here. So anyway, now that we've set up our project with virtual env, the next thing that we're going to do is install the Panda3D package. And again, I'm going to recommend that you use the same exact version of this package that I'm using here, because otherwise there's a good chance that something might have changed since then. So in order to install Panda3D, you're just going to want to, first of all, activate the virtual environment by running source, and then the path to your virtual environment. In my case, that's going to be venv/bin/activate. And once you've activated the virtual environment, you're going to install Panda3D by running pip install and then Panda3D. And the exact version that I'm going to be installing here is going to be 1.10.13. So you're just going to want to add that version to the end to make sure that you have the same one as me. Okay. All right, so when I run that command, you're gonna see that I get an error, and you might as well. And really this error is just occurring because the local version of pip that I'm using in this project is not the most recent one. So in order to fix that, you're just gonna run the last part of this command here, which is gonna be pip install upgrade pip. And if you enter that in a terminal and run it, that should allow you to run that pip install Panda3D command from before. And now our project has Panda3D installed. Okay, so now that we have Panda3D installed, let's create the file that we'll be running. This is going to be the entry point for our project, right? Basically, the file that will be running in our terminal in order to start the game. So let's create a new file here, and we'll call this main.py. Now, the name of this file isn't really important. You can call it whatever makes sense to you, but I'm just going to call it main.py because, well, that makes sense to me. So getting a basic Panda3D project up and running is actually a fairly simple thing to do. All we need to do is import something called show base from Panda3D. So what we're going to do is say from, And then the actual package path here is going to be direct.showbase.showbase. And note the difference in capitalization here. Showbase is all lowercase, and then you have Pascal case showbase, just something to keep in mind. And then we're going to say import, again, Pascal case showbase. So this showbase thing is just a class that we can extend in order to create basic Panda3D games, and it takes care of all of the window display stuff behind the scenes for us. So as you'll see, when we extend this class and then create an instance of that child class, that's going to automatically display a blank game window for us that we can start adding different objects to. All right, so let's extend this showbase class by saying class, and then you can call this whatever you want. I'm gonna call this my game, and then we'll extend showbase by adding parentheses and adding showbase inside of there. And now, just in order to get things started, we're gonna want to define the init method of this class by saying def init. And then we're just gonna want to make sure to call the init method of the parent class here, showbase, by saying showbase.__init, and then calling that with self, like so. All right, so that's really all that we need to do to get a basic game window. And again, that's all taken care of for us behind the scenes by this showbase class. So now, in order to get our game to run, all we need to do is create an instance of our MyGame class and tell it to run. And what that looks like is we're gonna say game equals MyGame, right, and call the constructor like so, and then we'll say game.run. All right, so this is pretty much the simplest Panda3D game that it's possible to write, less than 10 lines of code as you can see. So now what we're gonna do is run our program, and again, the good news here is that that's just like running any other Python program. We're just gonna run the command python main.py, and if we hit enter, what we'll see is this blank game window will be displayed for us, right? So again, this is taken care of for us by showbase. We don't have to worry about any of the behind the scenes mechanics of displaying this window, and you'll notice that you can also resize this window and make it full screen if you want. Now that we have the window displaying, let's start adding some objects to it. So we're gonna start off by seeing how to render a few different Minecraft blocks inside this window. And first of all, in order to quit a program that you've run, right, in order to quit a Panda3D program, you can either close the window, or in your terminal you can press Control-C. Those are both equivalent to each other. So anyway, the first thing that you're gonna wanna do here is add a few model files to your project, and I've made those available on the GitHub repo. I have them right here over in this window, so I have 4 different kinds of blocks. Perhaps later on I'll show you how I actually created these blocks using a program called Blender. And we also have a Skybox, which as you'll see is going to be used for displaying the sky background behind our scene. So you're going to want to download all of these from the GitHub repo, and once you have those, you're going to need to add them to your project. Now, I'm using Visual Studio Code, so what I have to do, at least on Mac, is I have to right-click inside this folder and say Reveal in Finder, and that will open up a window over here for me. And then I just have to take these files that I downloaded from the GitHub repo and move them over to there. All right, so now that we've added those to our project, the next thing that we're gonna do is load one of these models and see how to add that to the scene. Now, the good news here is that loading and displaying a block is pretty easy, as is loading and displaying pretty much any model. So what we're gonna do is, inside our init method, after we call showbase.init, we're gonna say loader.loadModel. And then, depending on which block you want to load first, I'm going to load the grass block first. You're going to just put in the name of that model file as the only argument to loader.loadModel. All right, so as you might expect, this loadModel method does what the name would suggest, and it loads one of those models and gives us a reference to that model. So what we're going to do is say grass block equals loader.loadModel. And now that we've loaded that model, we need to add it to the scene, and the way that we do that is by saying grass block.reparent to render, okay? So the first thing that I want to point out here is that loader and render, these are just two global objects that Panda3D makes available to us. Render is sort of the base node of the scene, so to speak. So if you think about this in front-end development terms, right, where you have the DOM, render here is sort of the document or body node of our game. So by saying grassBlock.reparent to render, we're just adding that block to the scene. Just a little detail there that you have to do whenever you want to actually add a loaded model into the window. So now that we've done that, that should be all we really need to do in order to see the block. So let's run our game again. And by the way, you do need to stop and restart a Panda3D game in order to see those changes take effect, right? There's not hot reloading by default. So let's just run our game again. And what we should see is, whoa, it's just a green screen. Well, the reason for that is when you add a block to a scene, or really any model, it's gonna start off at the origin, right? That is 0, 0, 0 in three-dimensional coordinates. And since that's also the default location for our camera that we're looking into the scene through, our camera right now is inside the block. Now, the good news here is that Panda3D automatically provides us with controls that we can use to sort of maneuver around the scene. So what you're gonna wanna do is right-click inside the window and drag up. And what you'll see is that instead of just a green screen, we have this grass block here. And if you use the middle mouse button, you're gonna need to click with the middle mouse button and drag around. You can see that that is our grass block. Now, you're gonna notice that there's something wrong with our block, right? It's pretty blurry to look at instead of nice and pixely like in the actual Minecraft game. So in order to fix this, what you're gonna need to do is install another package into your program, and that package is called Panda3D GLTF. Now, kind of a strange name for a package that we're installing. That basically allows our game to deal more effectively with these GLB and similar types of files. So what you're gonna wanna do is stop the program and run pip install, oops, there we go, Panda3D GLTF, and hit enter. And now if you run your program again with python main.py and zoom out, you're gonna see that it's the same thing. Now, this is something that's very important to understand when developing with Panda3D because you'll spend hours possibly trying to figure out why your models aren't updating. Well, the reason is that when working with certain types of model files, like these GLB files that we're working with here, Panda3D will actually cache those models behind the scenes. So in order to prevent this, you can either delete the cache, but since that's in different locations, potentially on different operating systems and different setups, I'm gonna show you a different way, and that is by using something called a PRC file. So what you're gonna do here is create a new file, and we'll call this something like settings, oops, there we go, .prc. And inside here, what you're gonna do is add a single line called model cache dir, and that's it. So basically what this does is by specifying this setting without any arguments, right? After this is where you would put the cache directory if you wanted to specify a different cache directory. By passing this without an argument, we're basically telling Panda3D that we don't want to actually cache those models. So you can close this file now, and the next thing that we're gonna need to do is import something called load PRC file, and this will actually load this settings file and set up Panda3D with it behind the scenes. So what this is gonna look like is we're gonna say from panda3d.core, we're gonna import load PRC file like so, and then we just need to call that before we define our mygame subclass. So what that's gonna look like, we're just gonna say load PRC file, and then the path to our file is just gonna be settings.prc. There we go. So now if we stop and restart our program here, what we'll see if we zoom out, which again you can do by right-clicking and dragging up, we'll see that the textures are now rendered correctly, right? They're no longer blurred out like they were before. Cool, so now that we're displaying a block with the correct textures, the next thing that we're gonna do is add a little bit of lighting, because currently all of the faces on our block are lit pretty statically, right? There's no differentiation between the different faces of our block. All right, so let's add a directional light here that will add a little bit more visual interest to this block, and once we add more blocks to our scene, it will also make it much easier to see where one block starts and another one ends. So adding a directional light in Panda3D is pretty straightforward. The first thing that we're gonna do is import a class called directional light from Panda3D core. So let's say from panda3d.core import directional light. And yes, we already imported something from Panda3D core up above. Honestly, so many imports come from panda3d.core that I usually just end up putting a lot of them on separate lines anyway. Cool, so now that we've imported that directional light thing, we're gonna go back down to the init method of our class, and underneath where we load and display our grass block, we're gonna set up a directional light, set its direction, and add that to the scene as well. So what this is gonna look like is we're gonna start off by saying main light equals directional light. All right, so we're creating an instance of that directional light class, and it wants us to pass a string, which is gonna be the name of our light. This just helps for debugging purposes mostly. So we'll say main light, and then underneath that, we're gonna attach the light to the scene by saying main light node path equals render.attach new node, and we're gonna pass the main light as an argument to that. Cool, so now that we have the main light added to our scene, the next thing that we're gonna do is set the direction of our light, and the way that we can do that is by calling main light node path dot set HPR. Now, set HPR is how you orient things in space, right? How you can rotate objects in the scene, and just in case you're curious, HPR stands for heading, pitch, and roll, right? So heading, which is the first argument here, is gonna be as if you turn your head side to side, right? So in other words, it's all in this plane here that the rotation takes place. So we're gonna set that to 30 degrees. The next one's gonna be pitch, which is if you look up or down, right? It's that sort of angle that you're turning the light or whatever it is that you're rotating in. So we're gonna set that to -60, and that will make it point down, by the way. Usually directional lights, since they're coming from something like the sun, will be pointing down at something. And then for the R component, which stands for roll, by the way, that's if you tip your head side to side, like toward your shoulders, that's the direction you'd be rotating it in. We're gonna set that to 0. Cool, so now that we have our main light, right, our directional light set up, all we need to do is tell our render object that we want that main light to illuminate things in our scene, and we do that by saying render.setLight and passing the main light node path as an argument to it. Cool, so let's rerun our game now, and we should see that the directional light will be illuminating our block. So let's zoom out again and rotate around with the middle mouse button. And sure enough, we see that the different faces on our block are lit differently depending on how they're facing in relation to our light. Now, one thing you're gonna notice is if you go around to the back of the block, all of the sides back here are just completely black, right? And that's because they're facing away from the directional light. Now, this is almost never what we want, mostly because it just doesn't look very realistic. So what we're gonna do is add another light to our scene called an ambient light. Now, ambient lights, unlike directional lights, light up the entire scene, right? All faces of all objects in our scene the same way. So let's go back to our code here, and we're gonna import another class called ambient light from Panda3D core. And then the setup for this ambient light is pretty similar to our directional light. We're just gonna say ambient light equals, and then create an instance of the ambient light class with a name. We'll just call this ambient light. And then underneath that, the next thing that we need to do is set the color of the ambient light. Now, unlike with our main light here, where we set the rotation of the main light by calling set HPR on the main light node path, With ambient lights, somewhat confusingly, we have to call that on the light instance that we create. So what we're gonna do is just say ambient light dot set color, and we're gonna set this, by the way, you need to pass a tuple to this method in order for it to work. And this tuple is going to contain 4 components representing red, green, blue, and alpha or transparency. Now you can play around with this if you want, but what I've found works out pretty well is if you set the RGB values to 0.3 and then the alpha value to 1, and that gives us a nice sort of balance of dark and light in the scene. Cool, so now that we've set the color of our ambient light, the next thing we're gonna do is add this light to the scene, just like we added our directional light. So let's say ambient light node path equals render.attach node, or attach new node rather, and we're gonna pass our ambient light as an argument to it. And then down here, we're gonna say render.setLight ambient light node path, and that will again tell our scene that we basically want to light up everything in that scene with that ambient light. Cool, so if we rerun our program now, we should see that the back 3 faces of our block are no longer black, right? You'll see that it's still lit differently, but if you go around to the back, while those faces are darker, you can still see them pretty clearly. Cool, so now that we've added lighting to our game, let's see how we can load some of the other models that we added to our project earlier, and we're also gonna see how to do some very basic terrain generation in Minecraft. Now, obviously, real Minecraft's terrain generation algorithms are quite sophisticated. In our case, we're just gonna be using our blocks to create a simple platform that the player can walk on and manipulate. So first things first though, let's see how we can load the different types of blocks into our program and display them. The good news here is that loading these other models like dirt block, sand block, stone block is gonna be the exact same thing as loading and displaying our grass block. So we'll start off with the dirt block, and for this we're just gonna say dirt block equals loader.loadModel, and the name of the file of course is dirtblock.glb. And now we're gonna say dirtblock.reparent to render, just like we did with our grass block. Now, if we run our code now, what you're gonna see is that instead of just having a simple grass block or a simple dirt block, the block that we're looking at kind of flickers a little bit, and that's because we're rendering both the grass block and the dirt block at the same point in space, right? And that causes, obviously, a little bit of glitchy behavior when it comes to Panda3D's graphics. So what we're gonna do is we're gonna move this block, right, the second dirt block here in space so that it's next to the original grass block. Now, one thing to note here is that each of these block models is 2 units on each side, with the origin, right, the place where the block's position is measured at, right in the middle of the block. Don't worry too much about those details if that didn't make sense. Just know that in order to put our blocks next to each other, all we need to do is adjust the position of our dirt block by saying dirtblock.setPosition, and we're going to pass in the X, Y, and Z coordinates here. So we'll say 0, 2, right? So we're gonna move it down the Y axis, which by default is away from the camera the way it's initially facing. And then we'll say 0 for Z. So this should put this block right next to our original grass block here. So let's stop our program and rerun it again. And if we zoom out and look around, sure enough, we'll see that our grass block and dirt block are right next to each other. Cool, so far so good. Let's do the same thing with our other block types. I'm just gonna copy the dirt block code here and paste it 2 more times. And for the next one, we'll load our stone block, and we'll say loader.loadModel stoneblock.glb, and we'll put this one at 0, -2, 0, right? So that's gonna move it in the other direction down the y-axis. And then we'll say stoneblock.setPosition and stoneblock.reparent to. And then for our sand block here, we'll say sandblock equals loader.loadModel, change that file name again, and we'll set this one to 0, 4, 0. And then of course we need to change this to sandblock.setPosition and sandblock.reparent2render. Cool, so once more, let's restart our game here, and we should see now that all 4 of those blocks are lined up next to each other, one after the other. Awesome, so we've added all 4 block types to our game, so the next thing that we're gonna do here is see how we can use a little bit of basic Python code to create a terrain, right, a world, so to speak, that our player can stand on. So what we're gonna do here is we're just gonna loop through, right? We're gonna have a few nested for loops, and we're gonna create a sort of 20 by 20 by 10 or so cube that the player will stand on top of and be able to eventually dig down through. Again, you can always adjust this and make the terrain generation logic more sophisticated if you want to, but just to make things simple, that's what we're gonna do. So first of all, though, let's actually separate some of this logic into helper methods so that it's not all inside our init method. What we're gonna do is for all of our model loading logic, we'll say define load models, and then that will take self as an argument. And what we're gonna do is for each of these blocks, we'll just say self.grassBlock, self.grassBlock, and this will allow us to access these models outside of this load models helper method. Cool, so let's do the same thing with our dirt block, self.dirtBlock, blah, blah, blah. And we'll do the same thing now with our stone block, and I'm just gonna copy and paste this, in fact, to do it more quickly. There we go, for our sand block as well, and that's all we need to do. So let's also do this with our lights. We're just gonna say define, set up lights, and we'll say self, and I don't believe that we need to reference these lights anywhere else in our code, so we can just leave self off of those variables. And now we just need to make sure that we call both of these helper methods from inside init. So we'll say load models, actually that needs to be self.load models, of course. And then we'll say self.load, or self.setup lights, that is. So that will set up the lights for us. So just to make sure we didn't mess anything up, let's restart our program, and we should see the same thing that we were seeing before. And sure enough, our blocks are still there. Cool, so now that we've done that, let's create another helper method that will take care of generating and displaying the terrain for us. And again, what we're gonna do is just create a larger cube out of our blocks. We're gonna have grass blocks on the top with dirt blocks underneath it. You can always feel free to make this a little bit more complex, just use your Python skills to do so. Cool, so let's say define, and we'll call this generate terrain. And what this is gonna do is we're gonna have 3 nested for loops. So the first one is gonna be in the Z direction, right? This is gonna be the different layers of our larger cube. So we'll say for Z in range, and let's say that we wanna make 10 layers of blocks, okay? So now that we've done that, we're gonna have another nested for loop. This will be in the Y direction. So we'll say for Y in range, and we'll make our terrain 20 by 20 blocks. So this is gonna be range 20, and then we'll do the same thing for X. We'll say for X in range 20, and this will give us ultimately a 10 by 20 by 20 cube made out of our blocks. So all that we're gonna need to do inside of here is similar to how we were able to just add each of our blocks to our scene by saying reparent2render. What we're gonna need to do instead is something called instancing, because essentially we don't wanna have to load a new model file, which is a pretty expensive operation each time we want to display that model. So in order to take each of these models that we've loaded and display it without reloading the file, what we're gonna need to do is create a new empty node in our scene and then instance the corresponding block to it. What that looks like is we're gonna start off by saying new block node equals render.attach new node, and we'll just pass a name here. We'll say something like new block placeholder. Oops, there we go. And then underneath that, what we're gonna do is set the position of our new block in space by calling new block node.setPosition. And what we're gonna do here is use the X, Y, and Z values from the for loops to figure out where this block should go. So what we're gonna do is we're gonna just say X times 2 minus 20, right? And the times 2 here is because each block is 2 units wide in each direction. And the -20 here is so that our platform will be centered around 0, right? Our platform is going to be 40 units in each direction because you have 20 blocks per side and 2 units per block. Cool, so that's the x. The y is going to look just the same. It's going to be y times 2 minus 20. And then for z, we're just going to say negative z times 2. So that will basically make the entire cube go downward below the origin. All right, so now that we've positioned the block node, we're going to instance the corresponding grass block or dirt block to this block node, depending on whether this is the top layer or not. So what we're going to do is check to see if it's the top layer by saying if z is equal to 0. Well, in that case, it's the top layer, and we're gonna set this to a grass block. The way that we do that is instead of calling reparent to render, we're just gonna say self.grassblock.instance2, and then we're gonna pass the new block node, right, that empty block node that we created up above as an argument to that. All right, so that will make it so that this single model is only loaded once and displayed as many times as we want it to. All right, so that's the top layer. Otherwise, what we want to do is instance the dirt block to the current block node by saying self.dirtblock.instance2 new block node. And that should be all we need to do. The last thing that we'll need to do as well, now that I'm thinking about it, is because we're displaying this terrain up above, we no longer need to display each of these models individually. So let's just remove these lines where we say reparent to render. We're just gonna load those models like so. And there we go. We just have our sand block, grass block, dirt block, and stone block all loaded. And one more thing that we need to do is, since we defined all of this logic inside this generate terrain helper method, we're gonna want to call that from the init method. So we'll say self.generate terrain. And now, if we run our code again, what we should see if we zoom way, way out is we have this giant platform made out of blocks. Now, up until this point, we've just been using Panda3D's default mouse controls to sort of look around our scene, but the next thing that we're gonna do is we're gonna see how to actually manipulate the camera and add controls that are a little bit more Minecraft-like, where you can basically look around the scene just by moving your mouse around. So first things first, let's set the original position of the camera so that the player is actually on this terrain. So what that's gonna look like is we'll create a new helper method. We'll just call this one something like setup camera. And what this is gonna do is it's gonna call self.camera.setPosition, and let's put the player about 3 units above the terrain, right above the top of that big block that we just created. And what that's gonna look like is we're gonna say 0, -3, 0, right? So the player is going to be right in the middle of that platform, about 3 units above it. And by the way, this self.camera object that we're referencing is very useful because it allows us to manipulate the camera that we're looking into our game's scene through. So as you've seen already, we can set the position, and we can also do things like rotate it, as you'll see. But anyway, when we want to start manipulating our camera programmatically like we're doing here, we'll need to tell Panda3D that we no longer want to use its default controls, right? You can't really have both. In order to disable the default controls, all you need to do is say self.disableMouse. And even though this method sounds like it's completely getting rid of all mouse functionality in the game, it's not. It's just turning off Panda3D's default mouse navigation functionality. All right, so let's run our game again. And by the way, you'll need to also call self.setupCamera here. And actually, now that I'm thinking about it, I was going in the wrong direction here with Y. This would put us in the middle of that big block we generated. What we want to do is put ourselves upward in the Z direction. And by the way, the default in Panda3D is that the positive Z axis is up, the positive Y axis is forward, and the positive X axis is to your right hand side. So by setting 3 for the Z axis here, we're moving the camera up. Cool, so let's try running this, and what we should see is that instead of starting in the middle of a block, our camera is now looking out toward the horizon of our world. Now at this point, before we start adding our own camera controls, there are two more things I want to add. One is the crosshairs in the middle of the screen that shows what the player is currently looking at and allows players to place and remove blocks. And two is, instead of this gray background here, it would be nice if we had some sort of blue sky in the background. So first of all, in order to display the crosshairs, what you're going to want to do, and I forgot this earlier by the way, but what you're going to want to do is download the crosshairs.png file from the GitHub repo, and you're going to add that to your project. And again, in Visual Studio Code, I'm going to say reveal in Finder, and I'm going to just drag this file over to here. And now that we have that crosshairs.png, we can display it on our screen. Now, since those crosshairs aren't going to be in the scene so much as part of what the camera is looking at, right? It's a sort of interface that's attached to the camera. The way that we're going to display those crosshairs will look like this. Inside our setup camera method, we're just going to say crosshairs equals, and then we're going to import something called on-screen image. All right, so we'll need to go up here and say from panda3d.core import on-screen image. And by the way, we'll also need to import something called transparency attrib after that. You'll see what that's used for in just a minute here. But now we can scroll down and we're gonna create an on-screen image here whose image keyword argument is gonna be equal to crosshairs.png. That's the file we just added to our project. And then we're gonna say position, and in order to put that right in the middle of our screen, we're gonna pass a tuple containing 0, 0, 0 as the arguments. And the last argument here is gonna be scale. And in order to not display that over the entire screen, we're gonna set this to 0.05. Okay, so that will give us a little crosshairs in the middle of our camera. Cool, so now that we have those crosshairs, we just need to make sure that the area around the crosshairs is actually displayed as transparent, right? If you open the file, you can see that there's quite a bit of transparency in this file. So what we're gonna need to do is just say crosshairs.setTransparency, and then we're gonna use that transparency attrib thing that we imported from above, .m alpha. Okay, so that will basically make all of the transparent parts of the image show up as transparent. Cool, so let's see if that crosshairs thing is working. We're just gonna rerun our program once more. And oops, it looks like something didn't work there, and that's because on-screen image actually isn't imported from Panda3D core. So we're gonna remove that there and say from, and this is gonna be direct.gui.onscreen image. And then we're gonna say import on-screen image. So let's try that again. We're just gonna run our program once more. And sure enough, we see that that nice little crosshairs appears in the middle of our screen. Now, in order to get a sky background to show up, no matter what direction we look in, there are obviously a few different techniques that you could use to achieve this effect, but the one that we're gonna use here is called a skybox. Basically, a skybox is a very large cube that we render in our game that goes around the entire scene, right? So basically, you're looking at the inside of that box, no matter what direction you look in. Now in our case, we already have a skybox that you should have got from GitHub. You're gonna wanna download that if you haven't already. And in order to display this thing, what we're gonna do is right above generate terrain, we'll just create a new helper method called setup skybox. And inside here, we're basically just gonna have to load this skybox.egg file inside the skybox folder and display it around our scene. So we're just gonna say skybox equals loader.load model, right? We've seen this method before a few times. And that's gonna be skybox/skybox.egg. Under that, we're going to make this box very large so that it's outside any object that might be in our scene. So we'll just say skybox.setScale, and we're gonna set that to something pretty big like 500. And underneath that, we'll say self.skybox.setScale. set bin, and then we'll say background 1. Now this, along with some of the other methods that we're about to write, makes sure that the skybox is always behind everything, even if something happens to go beyond the skybox bounds. All right, and then we're gonna say skybox.setBin, and then we're gonna say background and 1. And by the way, this method, as well as some of the other methods we're about to write, makes sure that this skybox appears behind all of the objects in our scene, even if those objects happen to go beyond the bounds of the skybox. So additionally, we're gonna say skybox.setDepthRight, and that's gonna be 0. And then we're gonna say skybox.setLightOff. This basically makes it so that the faces of the skybox don't react to that directional light that we set up earlier, right? That wouldn't be very realistic to have our skybox reflecting light differently off its different faces. All right, and the last thing we need to do is add the skybox to our scene by saying skybox.reparent2render. Cool, so let's call this setup skybox method from inside our init method now. We're gonna say self.setup skybox. All right, so now let's rerun our program. And what we should see is that we have this nice blue background being displayed. Now we can't look around at it yet because we disabled our camera controls, but if you want to, what you can actually do is go back to here and just comment out the disable mouse and set position lines, and you should be able to look around the scene a little bit more. So, oops, there we go. And sure enough, if you look around, you can see that we have this nice sky being displayed all around us. But of course, we're still using Panda3D's default camera controls to achieve this. So what we're gonna do next is see how we can add some more Minecraft-style navigation where the user can actually look around just by moving their mouse. Now, there are actually gonna be a few steps to making this work. The first step is that we're gonna need to do what's called capturing the mouse, right? Basically, capturing the mouse means that our window here will hold the mouse inside of it so that the cursor won't be able to leave the window, right? And actually the way that we're gonna do it will mean that the cursor will be stuck at the middle of the window. And then what we'll do is when we've captured the mouse, we'll use any attempted mouse movements, right? When the user tries to move the cursor away from that and we reset it, we're gonna use those attempted mouse movements to pivot the camera and look around. So first things first, let's see how we can capture the mouse. Capturing the mouse is actually a pretty simple thing to do because it's a very commonly used technique in video game development. So what we're gonna do here is start off by creating two different helper methods. The first one's gonna be called capture mouse, all right? And inside here is gonna be the logic for, of course, capturing the mouse. And we're gonna create another method called release mouse. Now, it's important that we implement both of these back to back and give the user access to both capturing the mouse as well as releasing the mouse, because after the game has captured the mouse, in some cases, it can be kind of hard to get out of it, right? In some cases, you have to actually force quit the game in order to get your mouse back. So that's why we're creating both of these methods back to back. But first of all, let's see how we can capture the mouse. The basic strategy here is that we need to create what's called a window properties object and tell Panda3D that we want the window to have a certain set of properties. And this might sound a little bit confusing. Let me just show you what that looks like. First of all, though, we'll need to import something called window properties from Panda3D up at the top. So we'll just say from panda3d.core import window properties. And once we have that, we're gonna scroll back down to our capture mouse method. And what we're gonna do is create an instance of that window properties class by saying window properties. And actually we'll just abbreviate this by saying properties, like so, equals window properties. And then the first thing that we're gonna do is say properties dot set cursor hidden, and we're gonna set that to true. All right, so this is gonna hide the actual cursor so that when we capture it and keep it in the middle of the window, we don't see that little cursor kind of wiggling around there. And now that we've hidden the cursor, the next thing that we're gonna do is set the mouse mode to relative, which is what will actually hold the cursor in the middle of the window. So what that's gonna look like is we're gonna say properties dot set mouse mode, and we're gonna set that to window properties dot m underscore relative, okay? And now that we've set those properties, we need to tell Panda3D that we want these properties to take effect by saying self.win.request properties, and we're gonna pass that modified properties object as an argument to that method. Okay, so that's how you capture the mouse. Releasing the mouse is really just gonna be the opposite. So if you want to, we can just copy these 4 lines from capture mouse and paste them in release mouse. And when we release the mouse, we're gonna set cursor hidden to false, and the original mouse mode before we set it to M relative is gonna be M absolute, right? This will allow the cursor to leave the window. Cool, so that's how we capture the mouse and release the mouse. So the next thing that we need to do now that we have these 2 methods created is call them at the right time. So what we're gonna wanna do is, first of all, when the game starts, we're gonna want to automatically capture the mouse. So all we need to do in that case is say self.capture mouse somewhere in our setup code, okay? So we'll just put it at the very end because it doesn't really matter at this point. All right, so we're gonna capture the mouse when the game starts, and then we're going to allow the user to release the mouse by pressing the escape key. Now, in order to set this up here, what we're gonna do is we're gonna create yet another helper method, and we'll call this something like setup controls, and this is where we get to tell Panda3D what keys we want to call which methods. So in our case here, what we're gonna do is we're gonna say self.accept, and the first argument here is gonna be escape, so we're telling Panda3D that we want to listen for the escape key to be pressed, and when that's pressed, we want it to call self.release mouse, and make sure to leave the parentheses off of that, right? We're just passing the method itself as an argument here. All right, so that's how we release the mouse, and the last thing here is we're gonna want to recapture the mouse when the player clicks in the window again. So the way that we're gonna do that is by adding another control here. We're gonna say self.accept, and we're gonna say mouse 1, right? That's the left click, and we're gonna say self.capture mouse. So in other words, when the player clicks inside the window again, we're gonna recapture the mouse. All right, so that should be all we need to do. One more thing though is we're gonna need to uncomment the self.disable mouse line and the self.camera.setPosition line that we commented out earlier in order for these things to all work correctly. And one more thing that we're actually gonna need to do as well is call this setup controls method. So let's add that down here in our init method. We're gonna say self.setup controls, and there we go. So let's restart our game now. And what we should see is that immediately when the game starts up, your mouse will disappear, right? You can't do anything with it. And if you press escape, your mouse will reappear until you click inside of it again, at which point it will be captured again. Cool, so now that we've seen how to capture and release the mouse, the next thing that we need to do, of course, is translate mouse movements into movements of the camera. So here's how this is gonna work. We're gonna need to give our game something called a task, which is basically just logic that our game will execute on each frame. Now, what this task is gonna do is it's gonna watch the mouse movements that the user makes, and it's gonna translate those into camera movements. So first things first, let's actually create this method, and we're just gonna call this something like update, all right? And then it's gonna take self as an argument as well as task. And one thing that's very important to do with tasks like this is at the end, you're gonna wanna say return task.continue, because otherwise Panda3D won't know when your task is done and it will sort of freeze up. All right, so anyway, now that we have this update method, we're gonna need to tell our game that we want it to call this method on each frame. And the way that we do that is inside our init method, we're gonna say task manager, right? That's abbreviated MGR dot add, and we're gonna pass self.update as an argument to it. And then as the second argument, we need to give this task a name, which we'll just call it update. Cool, so now that we've added this update task, we can be sure that it's going to be called on each frame, which means that we just need to see where the mouse is moving and adjust the camera accordingly. So here's how this is going to work. The first thing we need to do is see how much time has passed since the last time update was called, right? Because the frame rate of a game can vary over time, and so if the frame rate is going very quickly, we don't want the user's camera to swing around more quickly than if the frame rate's going more slowly. So the good news here is that Panda3D makes this pretty easy to figure out. All we need to do is create a variable called dt and set that equal to global clock.getDT, right? This dt tells us how much time has passed since the last time this update method was called. And now that we have that dt variable, or delta t, if you want to think about it that way, the next thing that we need to do is figure out how far the mouse has moved since the last time update was called. So what this is going to look like is we're going to say md equals self.win.get pointer 0, right? This will get a reference to the cursor, and we can find out where the cursor is by saying mouse x equals md.getX. And getting the mouse Y position is pretty much just the same thing, but with mouse Y equals md.getY. All right, so now that we have the current mouse X and mouse Y, we're gonna need to figure out how far the mouse has moved. And in order for that to work, we're gonna need to create two member variables that will store the last position of the mouse. All right, so what you're gonna wanna do is go down to capture mouse, and when the mouse is captured, we're gonna wanna run this logic and store the mouse position that the mouse was captured at as the last mouse X and last mouse Y. So that'll look like this. We'll just say self.lastMouseX equals md.getX and self.lastMouseY equals md.getY. And now we can figure out how far the mouse has moved by saying mouse change X equals mouse X minus self.lastMouseX. And then same thing for the mouse Y, mouse change Y equals mouse Y minus, oops, there we go, last mouse Y. And now we can use these things to rotate the camera accordingly. All right, now this does involve a bit of math, so I'm just gonna copy and paste this from the GitHub repo. You can do the same thing, or you can type it all out yourself if you're feeling brave. But the basic idea here is that we say self.camera.setHPR. Remember that this sets the rotation of an object in our game. All right, and we're basically just taking the mouse movements and translating those into rotations in the H and P directions. And you'll also notice this thing called self.camera swing factor. That's just something that you can set here. I'm gonna say self.camera swing factor equals 10, and that basically just makes the camera swing around a little bit faster than if we didn't have that there. You can feel free to play around with this value and see if you can get it to your liking, but I found that 10 feels pretty close to how the real Minecraft game feels. Cool, so that's the camera swing factor, and there's also current H and current P in here. Those we can get from the camera itself by saying current H equals self.camera.getH. All right, and then we can get the current P rotation by saying current P equals self.camera.getP. And the last thing that we need to do here is, after we've readjusted the camera, we need to reset the last mouse X and last mouse Y member variables so that we can do the same calculation next time. That's gonna look like this. We're gonna say self.lastMouseX equals mouse X and self.lastMouseY equals mouse Y. Cool, so let's give this thing a try. We're going to rerun our code, and if everything goes well, we should be able to now look around inside the scene, right? We can look up, we can look down, we can look right and left. But one thing that you're gonna notice is after you release the mouse with escape, it'll still continue to look around. Now, assuming that you don't want this to be the case, all we need to do is add a simple Boolean variable indicating whether or not the mouse is currently captured. All right, so what that's gonna look like is inside the capture mouse method, we're gonna say self.camera swing activated. That's what we'll call our member variable there. And we'll set it to true. And then we'll set that same member variable to false inside the release mouse method. All right, so we'll say equals false. And now we just need to check to see what the value of that variable is inside our update method by saying if, and then we'll say self.camera_swing activated, and we'll put all of this camera swing code inside of there, and you will want to leave the task.continue thing out of there, okay? So let's try this again. We're gonna restart our code, and we should see that sure enough, we're able to look around, and when we press escape, it no longer follows our mouse. And then of course, if we click back in, it'll follow our mouse again. Awesome, so now that we're able to move the camera around with the mouse, the next thing that we're gonna do is allow the player to move with the keyboard keys. And the first thing that we need to do is create something called a key map that will keep track of what keys are held down at any given point in time. All right, so what this is gonna look like is we're gonna scroll down and find our setup controls method, and inside there, we're gonna say self.keymap equals, and this is just gonna be a dictionary whose keys, right, whose dictionary keys that is, there's an unfortunate overlap in vocabulary there, whose dictionary keys correspond to the different keyboard keys that could be pressed, and the values for each of those keys is gonna correspond to whether or not that keyboard key is currently held down. That sounds confusing, but it's actually quite simple. All that we're gonna do is we're gonna say forward, and that's gonna be false, and then we'll do the same thing for backward, and then left and right. And then we'll also have keys for up and down. All right, so basically what we're gonna do is we're gonna have the keyboard keys W, A, S, D, and then the left shift key and the space bar correspond to each of these key map entries. And when one of those keys is pressed, it's gonna set that key entry to true, right? So in other words, we're gonna be able to use this key map inside our update method to tell whether or not a key is being held down and move the player through the scene accordingly. So what this is gonna look like now is just like we said self.accept for escape and mouse 1, we're gonna do the same thing for all of those buttons, and we're gonna have them call a specific method that will update this key map and change the corresponding entry to true. So what that's gonna look like, let's just create that method down below real quick. We're gonna say update key map, and all that this is gonna do is it's gonna take a key as an argument, right? So that's gonna be forward, backward, left, right, etc. And then it's gonna take the new value that we wanna set that to as an argument as well. And all that we're gonna do here is say self.keymap key equals value. All right, so that might seem like kind of a silly method, but basically what we're gonna do here now is when things like the W key are pressed, we're gonna call self.updateKeymap with the arguments, and by the way, the arguments that we want to pass to this are specified as a list, forward, since W is going to be the forward key, and we're going to set that to true. Now, when the W key is released, which we can listen for by changing this string to W up, we're going to want to set that forward entry to false. Okay? All right, and then we're just going to do that for the rest of our keys. So let's just copy this and paste it a few times here. All right, so we'll say W. A is going to be left, all right? So we'll say A and A up. That's gonna be left true and left false. Then we'll do the same thing for S. This is gonna be backwards, so we'll change that to backward true, and S up is going to be backward false. And then we'll do D, which is going to be right, so let's change this to D and D up, and then that's gonna be right true and right false. And for up and down, let's just make two more for those. We're gonna copy this and paste it. Up is going to be the space bar, so we'll say space and space up. And here, let me just scroll down a little bit there. There we go. That's gonna be up true and up false. And for the left shift key, which in Panda3D is L shift, oops, there we go, and L shift up, we're gonna set that to down and down. Okay, so all this code that we just added here has the effect of keeping our key map in sync with what keys are actually being held down by the user. So what this means now is inside our update method, if we scroll back up to that, we can now check what keys in our key map are true and make the user move accordingly. All right, so this actually involves a good bit of math and trigonometry. So what I'm gonna recommend you do is just copy this code from the GitHub repo. Look for 3 lines that say X movement, Y movement, and Z movement. And you're gonna copy that through where we say camera.setPosition. So in other words, let me just copy that and paste that for you. Here we have the last line, which is camera.setPosition. And then we have X movement, Y movement, and Z movement. And actually, this should say self.camera.setPosition. All right, so we have the last line here, and the first line is X movement. Now, you'll notice that we also have this player move speed thing. That's just something that you can toggle to change the speed at which the player moves. I'm gonna set that to 10, but again, you can play around with that to see what feels right to you. And we also have sine and cosine, as well as pi somewhere, which you can rephrase. And we also have sine and cosine, as well as I believe pi is hiding somewhere. So what you're gonna wanna do is import those from the Python math library by saying from math import pi, sine, and cosine. All right, so now that we have those, we're also gonna need to copy and paste the helper function degrees to radians. So I'm just gonna copy that and paste that above my game. And that's used down below to convert the camera's rotational measurements to radians for Python's built-in sine, cosine, etc. functions. Cool, so anyway, that should be all we need to do in order to move the player. And as you can see, basically this is just one big block of if statements checking to see if each of the keys is pressed down, and if it is, we're adjusting the player's movement in different directions accordingly. So let's try running this now. We're gonna restart our game, and what we should be able to do now is press W, A, S, and D, and that should allow us to move around the scene, right? So you can move to the left, you can move to the right, you can move backward, forward, and then up and down as well. Now you're gonna find that the player can go down through blocks as well, and that's because we haven't set up any collision detection. That's something that maybe we'll do later on. But anyway, the player is now able to move around the scene, which is pretty cool. All right, so now that we can move the camera around with the mouse and we can move the player around with the keyboard keys, we're finally ready to start implementing the core functionality of our Minecraft game, which is giving players the ability to remove and place blocks. Now, in order to do this, what we're gonna need to do is set up something called collision solids, both for the blocks themselves and for the player's line of sight, right? If you picture that the player currently has a line that's going from our camera through that crosshairs on the screen, we're gonna want to find out where that intersects with one of the blocks so that we know which block a player is currently looking at, and we can know that the player either wants to add a block on top of or next to that one or remove that block depending on which mouse button they press. So anyway, that sounds a little bit complicated, but it's actually pretty straightforward. What we're gonna need to do is when we set up our camera, we're gonna need to use something called a collision ray and have that point from the camera forward. And after that, we're gonna need to add a collision box to each of the blocks that we add to our scene. So starting off with the collision ray though, well, first of all, let's import these things up at the top, I suppose. So what we're gonna wanna do is say from panda3d.core import, and there's a good list of things that we're gonna need to import here. The first one is something called collision traverser. You'll see what that does in just a second. Collision node, collision box, that's gonna be for our blocks, then collision ray for our player's line of sight, and finally something called collision handler queue, which we'll be using to figure out what items are intersecting in our game. Cool, so now that we've imported those things, let's go back down, and inside the method where we set up our player's camera, All right, let's just go down to there, set up camera. We're gonna define a collision ray coming from the camera out into space. That's gonna look like this. We're gonna start off by creating something called a collision traverser. And collision traversers are basically just objects that watch all of the other objects in our scenes and keep track of which ones are colliding with each other. So what we're gonna do is say self.cTrav, and that's kind of a funny abbreviation, but this is actually a placeholder that Panda3D gives us on the showBase class so that it will automatically check to see if items are intersecting on each frame. So we're gonna say self.cTrav equals collision traverser and create an instance of that. And then we're gonna create a collision ray, which is gonna be our player's line of sight. So we'll just say ray equals collision ray. All right, and then the ray class actually contains a very useful method that will set the position and orientation of the collision ray according to the camera in our game. And that's called ray.setFromLens. And all we need to do here is pass something called self.camNode. Right, this is the node in our game that contains the camera we're looking through. And then as the second argument here, we need to pass a tuple with the values 0, 0. That basically tells us that we want the ray to go from the direct middle of our screen, right? The middle is 0, 0. And that should be all we need to do for that. So now that we've set the ray and sort of attached it to our camera, the next thing that we need to do is create a collision node by saying ray node equals collision node. And then we'll give it a name, we'll call it line of sight. Cool, so now that we have the ray node, we're just gonna say ray node.add solid and add that collision ray to it. And after that, we're gonna say ray node path equals self.camera.attach new node ray node. All right, so don't worry too much about the details here. Just know that this is wiring everything up so that that line of sight will follow our camera as we move it around, and it will tell us basically what blocks the player is looking at. You'll see how that works in just a second here. But one more thing here, we're gonna need to say self.rayQ, and we're gonna create a new instance of something called collision handler Q, which we imported up above. This basically manages a list, more or less, of items that are intersecting in our game, and you'll see how we use that shortly as well. So now that we've done that, we just need to say self.cTrav.add collider, and as the first argument, we're gonna pass our ray node path, and as our second argument, oops, my autofill added some extra arguments in there for some reason. The second argument, we're gonna pass the ray Q. So basically what this is doing is it's telling Panda3D that all of the collisions that happen with this ray node path, which again is our user's line of sight, are gonna be stored in this ray Q thing. So again, you'll see how we use that in just a minute here. But anyway, now that we've set up that line of sight collision ray thing, we're gonna do something very similar for all of the blocks in our game. So what we're gonna do here is if we scroll down to our generate terrain helper function, underneath where we create our block and instance one of the models to that block node, we're gonna create a collision box, which basically tells Panda3D the bounds at which something will be colliding with one of those blocks. Now, the reason that we need to do this in the first place is because by default, the things that we display in our scenes, Panda3D will treat sort of like ghosts, right? Where they appear there, but they don't really have any solid mass to them. So by adding what are called collision solids, such as this collision box that we're about to add here to objects in our game, we're basically telling Panda3D that we want to know when something collides with these things and be able to handle it accordingly. So what this is going to look like now is we're going to say block solid. That's just what we'll call this collision box we're about to create here. And then we're going to say collision box. And the arguments that we pass to this are going to be the three-dimensional points of the opposite corners of the collision box. All right, so since our blocks are all 2 units on each side, the bottom corner is going to be -1, -1, -1, and the opposite corner is going to be 1, 1, 1. All right, and note here that we don't have to adjust this position according to the position that we move the block node to, because by default, this will be a relative position to the node that we add it to. Again, if that doesn't make sense, don't worry too much about it, but that's just something to keep in mind. So now that we've created that block solid, we need to create a new collision node by saying block node equals collision node. And this asks us for a name. We're just gonna say something like block collision node. You might want to give that some kind of unique string, like use the X, Y, and Z coordinates in there for debugging purposes, but for now we'll just give it the name block collision node. And now we just need to say block node.add solid, and just like we did with the collision ray, we're going to add the block solid collision box to that block node. And finally, we need to say collider equals new block node dot attach new node, and pass the block node to it. And last but not least, I know that this is a lot of code for just wiring up collision handling, but don't worry too much about the details if you don't really know why we need all these things. Just know that they're necessary. We're just gonna say collider dot set Python tag, and then we're gonna say owner and set this to the new block node. Now the reason that we're doing this, right, and by the way, the new block node is the thing that we instanced the grass block or dirt block or whatever to earlier. This is going to allow us to access this block node when the user clicks on a block, and it's gonna allow us to remove it if we want to. So anyway, that's how to set up the collision solids, and at this point we should be able to determine what the player is looking at by using this ray queue that we defined up above. So here's how this is gonna work. When the player clicks the left mouse button, we're gonna want to remove whatever block they're currently looking at, right? So whatever block falls directly under this crosshairs in the middle of the screen, we're gonna remove. All right, now in order to do this, there are a few steps, so bear with me here. The first thing that we're gonna wanna do is find where we set up the controls. I'm just gonna search for that here. Set up controls. And instead of having the left mouse button directly call capture mouse, we're gonna create a sort of intermediary method called handle left click. And the reason we have to do this is because you can't pass multiple methods to the self.accept method in Panda3D. So what we're gonna do is just add a handle left click method here. And all that this is gonna do is say self.capture mouse, if we haven't already captured the mouse, of course. And we're also going to say self.remove block. Now this remove block method is what we're gonna need to define next, and that's where things get interesting. So you can really put this method wherever you want. I'm just gonna put it underneath this handle left click method because, well, we're already here. So let's say define, and we'll say remove block. And while we're at it, let's also define a method called place block. So we'll just say define place block, and we'll implement that one after we're done implementing the remove block method. Cool, so for removing the block, what we're gonna do here is we're gonna need to figure out what block is closest to the player. So if you go back to the game window and take a look at the crosshairs, you can imagine that there's more than one block that's intersecting with that line of sight, right? The line of sight goes pretty far off into the distance. So all that we're interested in is the block that's closest to the player. Now the good news here is that Panda3D makes this pretty easy for us because all we need to do is take a look at the ray queue that we set up above, and it actually allows us to sort items in order of how far away from you they are. So here's what that's gonna look like. We're gonna start off by checking to see how many blocks the user's line of sight is intersecting with. So that's gonna look like this. We're gonna say if self.rayQ.get number of entries. And if that's greater than 0, then that means that the user is looking at something, right? That collision ray that we defined is intersecting with one or more blocks. And in that case, what we're gonna wanna do is sort the entries so that we get the closest block first. And again, the good news here is that Panda3D makes it super simple. We can just say self.rayQ.sort entries. And at this point, we can get the closest block to the player by saying ray hit, that's just what we'll call it there, equals self.rayQ.sort hit.rayQ.getEntry, and we want to get the first entry there, which is defined as 0. Cool, so this ray hit thing at this point is an object that contains data about the collision that's occurring. And we can use it to figure out which block is being hit by saying hit node path equals ray hit.get into node path. That's kind of an interesting method name there, but basically in any collision there's a from object, right? That's the object that's doing the colliding. In our case, that's going to be the user's line of sight collision ray. And there's an into object, which is the object that's getting run into by the other one. In our case, that's going to be the block. So now that we have this hit node path, what we're going to do is we're going to get the actual object in the scene that belongs to and delete it, right? So this is where we remove the block, and that's also where this Python tag thing comes in handy, because this allows us to find the ultimate node that the collision node, the model, and everything belong to and remove it. So what this is going to look like is if we go back up to where we're defining our remove block method, we're just going to say hit object equals hit node path dot get Python tag owner. All right, so we're getting the node that this belongs to, and now we're going to remove it by simply saying hit object dot remove node, right? That will get rid of the node and all of the associated resources. All right, and just by the way, at this point, the user will be able to remove blocks no matter how far away the blocks are. Now, if you want to prevent that, all you need to do is find the distance that that block that you're removing is from the player, and if it's within a certain radius, allow the player to remove it. So what that looks like, again, this is one of those situations where Panda3D makes it pretty simple for us. We're just going to say distance from player equals hit object dot get distance, and we're going to check the distance between that and the camera like so. And then we're just going to say if distance from player is greater than some arbitrary value. I've found that 12 feels about right. You can always adjust this later on. Well, in that case, we're going to remove the node, and oops, actually that should be less than 12, not greater than 12. And one more thing is, in order to prevent memory leaks here, we're going to want to remove this Python tag when we remove the node by saying hit node path dot clear Python tag owner. Okay, so there we go. Now at this point, we should be able to remove blocks. So let's test this thing out and see if it works. What we're going to do is rerun our code. And if we go back to our window here, we should be able now to left click on blocks, and sure enough, we see that they disappear. Now, one thing that I'm noticing here too is that the field of view that we're looking through is pretty narrow. So if you want the player to be able to see more in their field of view, that's actually a pretty easy thing to adjust. You just need to go into where we're setting up our camera. So we'll say set up camera, and where we set the position, we're gonna say self.camLens.set field of view. And I found that 80 is a pretty good value for this. Again, this is something that you can adjust according to your tastes. So let's restart the game one more time, and we should see that the field of view now is a little bit wider, and that's very nice because it allows us to see more of the world that we're in. So the last thing that we're going to do here is allow the user to place blocks by right-clicking. So let's head back to our code here, and what we're going to need to do is implement the place block method that we created earlier. And by the way, the remove block doesn't need this return statement at the end. But for placing the block, basically half of the logic is going to be the same, right? This part where we tell what block the user clicked on. But after that, we're going to need to tell what face the user clicked on, right? In other words, what face of the block is the user looking at? And we're going to need to add another block off of that face. So the good news here is that that's not as hard as it sounds. What we're going to do is, first of all, we're going to say self.rayQ.getNumber of entries, and you can copy actually pretty much the body of this remove block method just for a start. All right, that'll make it so that we don't have to write nearly as much code. So now, what we need to do is after we've gotten this ray hit collision entry object thing, we need to find out what face of the block the user clicked on. Now, this is actually surprisingly easy because all we need to do is say normal equals ray hit dot get surface normal, and we need to pass ray hit dot get into node path as the argument here. And actually here we can put that up above from what we had before and just pass in hit node path like so. All right, now when we talk about normal and get surface normal here, what this refers to, right, a normal is basically a vector that's perpendicular to a face, right? So if you picture a cube and you have, let's say, the top face, the normal is going to be a vector that's pointing straight up from that face. And basically this is useful for this exact situation where we want to know what direction is up for the face that we clicked on. If this isn't making sense, by the way, don't worry too much about it. Just know that this is how we tell what face is being clicked on and where we should place this new block. All right, so now that we have this normal, the next thing that we're going to do here is after we've gotten the hit object and we've gotten its distance from the player, instead of removing that block that the player is looking at, we're going to create a new block and use that normal vector that we got up here to position the block correctly. So what this is going to look like is we're going to say hit box position, and we're just going to say equals hit object dot get position. All right, that's the block that the player clicked on. And then what we're going to do is we're going to say new block position equals hit box position, and actually this should be hit block position to use the correct terminology here. We'll say hit block position there. And then we're gonna say plus normal times 2. All right, now the reason that we're multiplying this normal thing by 2 is because the default length of a normal is 1, and the side lengths of our cubes are 2. So again, don't worry if that doesn't make sense, just know that this gives us the new position for our block. And now, in order to place a new block, what we're gonna do is basically everything that we had inside our generate terrain helper method. Now, instead of copying and pasting and duplicating all of this code, what we're gonna do is just copy basically all of this code from inside the innermost for loop. And we're just gonna create a helper function called place block. And what that's gonna do is it's going to take the X, Y, and Z positions of a block and run all of that code for that position. So let's just paste all of that code there and adjust the indentation accordingly. There we go. And oops, I went one too far. Let's go back. Cool, so now that we've got this place block helper method, what we're gonna do is remove the new block node.set position thing as well as the grass block and dirt block logic. We're gonna move that back into our nested for loop structure here. And then what we're gonna do is instead of calling new block node.set position, we're just gonna call place block. And actually, I'm realizing that I reused this place block name from before. Let's call this something like create new block. That might make more sense there. And we'll change this to self.create new block. And for the X, Y, and Z values, we're gonna pass these. And we'll also wanna pass the block type as well. So that's gonna be the fourth argument here. We'll say type. And now, depending on that type, we'll say if type equals, and we'll just use strings like grass or dirt to identify this. We'll want to instance different models to that block accordingly. So if it's grass, we'll instance the grass block. If it's dirt, we'll instance the dirt block. All right, so we'll just say else if type is equal to dirt. And then we'll say self.dirtBlock.instance2. And now we can remove this if statement from inside our generate terrain method. And for the type, we're just gonna say grass if Z is equal to 0. Otherwise, what we wanna do is pass dirt and display a dirt block there. Cool, so now that we have this create new block helper method, we can use this same thing inside our place block method up above. And now that we have the new block position, we're just gonna say something like self.create new block. And the X position is gonna be new block position.X. Y is gonna be new block position.Y. And Z is gonna be new block position.Z. And for the type, we'll just say that we're automatically gonna put grass blocks down. And actually, one more thing that I forgot is if we scroll back down to our create new block thing, we need to call new block node.setPosition with the X, Y, and Z values there, right? I forgot that, and the result of that would be that all of the blocks would be displayed at the origin, one on top of the other. And of course, we also need to make sure that right-clicking the mouse calls this place block method, which it currently does not. All we need to do for that is go up to our setup controls method and add self.accept mouse3. Mouse 3 is the right-click button, by the way, not mouse 2. And then we're gonna make this call self.placeBlock. Okay, so let's restart our program here. And what we should be able to do now is look around and right-click, and sure enough, we're now able to place blocks as well as remove them. Pretty cool, right? So one more thing that we're gonna do here, since we have all of these different block types, is we're gonna allow the player to select different block types that they wanna place by using the number keys. Now, the way that we're going to do this is by adding another helper function here. We'll call this something like set selected block type. And what this will do is it'll just take a new block type and store that in a member variable. So we'll just say something like self.selected block type. Oops, that should just be selected block type. There we go. And we're gonna set that equal to whatever that new type is. So now, in order to allow the player to use the keys 1, 2, 3, and 4 to select between the different types of blocks, we just need to use self.accept with those different keys and pass different values for this type. So what that looks like is we're just gonna say self.accept1, and for that we'll call self.setSelected block type, and we're gonna call that with the grass type. So grass will be 1, and then for dirt we'll say 2, and we'll change that argument to dirt. Then we'll do 3 and 4 here, and those will be sand and stone respectively. Cool, so now we just need to incorporate this selected block type member variable into placing a block. So let's just scroll back down to our place block method, and for the type, instead of just hard coding grass, we're gonna say self.selected block type. Oops, I'm not sure why it's not autofilling the member variable for me there. So that should be just selected block type. And, oh, one last thing, we need to actually go back up here and inside the init method, or elsewhere you could do it, I suppose, but we'll just do it inside the init method. We're gonna say self.selected block type and set that equal to grass. So that'll be the starting block type. And one more thing actually is for the set selected block type, we need to actually add the self argument to that. That's something that I just forgot there. And one more thing here is we need to go back down to the create new block method and add the sand block and stone blocks to this if statement. So we're gonna say else if type equals sand. We're gonna say self.sandBlock.instance2, and if the type is equal to stone, we're gonna say self.stoneBlock. And now, if we rerun our game here, we should be able to place those 4 different types of blocks by using the number keys, and sure enough, we see that we're able to do that. So again, feel free to play around with this more, feel free to add your own block types in there, change the speed that the player moves at. There's really a lot of places that you can go from here. So anyway, that's the game. Hopefully you've enjoyed seeing how to use Panda3D here to create a simple Minecraft clone. Obviously, as I've already said, there's lots of room to expand this game using the topics that we've covered in this video. If you've enjoyed what you've seen here, feel free to check out our extensive library of IT and software development training content on cbtnuggets.com, and remember to subscribe to this channel. So, See you next time.